Right.
Yeah. Thank you.
All
Thank you
right.
for the delay, though, sir.
Good evening, everyone. I am Nilotpala and be your host for today. For today's live session, we have with us Mr. Sourish Banerjee, who is the founder and CEO of Arkvien AI and Arkvien AI. Mr. Sourish is an entrepreneur, data analytics expert, and digital solution architect. He's also an avid innovator and technology enthusiast with an extensive experience of 13 years. We also have Mr. Debanjan Chaudhuri, who is an AI expert and CTO at Arkvien AI. Mr. Chaudhuri is a computer scientist with over 10 years of experience. He is an eccentric researcher, an ardent lover of mathematics, a computer programming, and a human art and culture. Uh, a firm believer that AI singularity is not that far. This man, his main areas of interest are machine learning, especially deep learning for natural language processing and computer vision. He's currently working on question answering systems, automatic relation extraction from free text, computer vision, etc. Let us now know about Arkvien AI. This artificial intelligence studio startup incorporated in 2021 with an aim to accelerate the digital revolution by bringing back data trust to organizations around the world. Sharing data in the enterprise world can be very difficult owing to factors like breach of trust or legal or government foundations. I'm really looking forward to the session, sir. I think over to Mr. Sourish Banerjee now. I think you're on mute, sir.
Sorry, my bad. Thanks, Nilapala. Thanks for the introduction. And also, I would like to thank you and your team for hosting this session. So, in this session, we're going to discuss, I and Debanjan both going to discuss about the data obfuscation and the privacy technique. Let me share my screen and then we can start discussing on that. Guys, let me know if you can see my screen. Yeah.
It is visible.
That's great. So today's agenda for this session is how we can build the data trust into the wild. That means if you can imagine a piece of paper you just put into the road, and if anyone sees that, they should not be able to understand what is written there. So by that way, we can build the trust. And today I am Debanjan, as you have introduced us, and we will actually talk about that. Debanjan, over to you.
Thank you, Sourish. So, hi, Nilapal, and hi, all. Thank you for the introduction. And yeah, so I will start the presentation with a small quote. So, a ship in harbor is safe, but that is not what ships are built for. Definitely, if you stay at home, you are also the safest, and you don't have any chance of accident. The probability is very less. But that's not what we are meant for. We are meant to go out and explore the world in a way. So data is also like that. Data is not supposed to sit at someone's desk or at someone's hard drive. It is supposed to be explored, and some information has to be extracted for making decisions and whatever. So saying that, and putting that into context, I want to start the presentation we are already being introduced by Nilatpala. So I will not I will skip that slide. So this more on a privacy scandal that happened. I think all of you are aware of that. In 2014, a Facebook quiz was done where a lot of participants has given their and their friends information, which is apparently stored there in Facebook for 87 million users. And then this is being exploited by Cambridge Analytica in 2015, as you all know, and has been used for election to like which can give information about psychology and how to get votes for different parties. And so this is an exploitation or an example of exploitation. We are here to have a like our solutions for Arkvien. We are trying to get rid of this problem for data, so that like whenever you are doing a ML model on data, you can be sure or guaranteed that this kind of issues will not happen in the future, because data privacy law, especially in Europe and US, is very strong, like as you all know, GDPR. So coming to that, so if you are using a ML model in production, like machine learning model on your data, there are certain risks to that. Like some of the risks are relating to data, where you can suppose you have some text or some images and it is being obfuscated, or some of the information, important information, are removed from there. But at the same time, based on the context, it can also be like re-inferred or re-identified. All the person, like suppose a tweet where some names are removed, but based on the context of the tweet, the names can be re-identified with a Google search or something like that. And similar is reconstruction attack. So these are data attacks, and then there can be attacks on the models itself, where like you can easily see or understand the parameters of the model giving some data, so you can actually have some understanding of how the training data looks like. So that is also, and the training data can be some important business data which people have used to train the model, or data scientists have used. So this is another form of attack. Similar is membership inversion attack. Also, it's kind of exploiting the data that is underneath, which is being used to train the model. Uh, so more on this, like there is also this attack that has been happened or has happened in 2010 on the US census data. So there are some like we'll share this presentation with you, so you can also look more into this problem. I mean, they came up with a solution in 2020, but this is a very interesting case that we always like try to present and show that how like if the data is exploited, how vulnerable we as people. So yeah, so but the thing is, it's all not that green. So definitely, like there can be different attacks, but there is something called privacy preserving machine learning, or PPML. Today we are mostly going to talk about that. And so yeah, more on that. Like I want to show you an example of like differential privacy. It is a part of PPML. And in real world, what happens is like we have different data. So suppose there is a company where we have two people, or like a journalist comes up and wants to survey the average salary of the company. And then they ask, they have signed NDA and everything, and then they ask for the average salary with these two people. And then one of the data scientists, suppose John, um, uh, like runs a query on the average salary, and like gives the salary to the journalist. And then they can write a report on that. Okay, like for this company, for which can be like a MNC or anything, so this company is paying average salaries of this. But suppose tomorrow a new employee Vinita joins the company, and then again this journalist wants to exploit somehow. So suppose Vinita has given a post in social media that I have joined this company X, and then this journalist wants to see that how much is her salary, or he wants to sell this information to someone, so that, I mean, they can be benefited for that, like it can be insurance or anything. So then what, he again asks John for the salary or the average salary. Now you can easily infer this. So if the average salary for 100 people suppose was X, and now it's like Y, then you can easily understand what is the salary of Benita, for instance. So we want to stop this using differential privacy. So what happens is like we have a lot of sensitive data. Suppose like for training a machine learning model, you need the data in the form of input and output X and Y. So what we do is this data owners, we put the data into some trusted data center or curator like us, and then we sanitize the data using differential privacy, so that when you are getting the sanitized data, then your data is relatively safe. Even the models which you are using to train this data can infer all the statistics. So basically our guarantee is like you can make sense out of this data, you can do all the machine learning and data analytics on top of this data, but at the same time your data will be private. So coming to the example we had in our running slides. So now in this case, although like what the other third party will see is like the salary is 58,000, average salary is $58,500 for instance, of pounds here, for 103 employees. But when a new employee is added, we will see like 99 employees, but the average salary is 58,600 pounds. So he can't really make any sense out of it. So in this case, the salary of Vinita is safe, and like not much exploitation can be done on top of this data. Yeah, so another important part is like in data science, there are different kinds of data sources like text or on unstructured data, images, audio, everything. So differential privacy can work on all of them, and we use different differential privacy algorithm on all kinds of data to keep it safe and secure for companies. Yeah, over to you, Sourish. You can explain a little bit about the platform. Let's say.
Thank you, guys. Thank you, Debanjan, for this explanation on the differential privacy. So, guys, the reason behind choosing this particular topic and the differential privacy is, as we all know, the academia and the industry doesn't always work in a similar way, right? So from our own experiences, we have seen when we were in that academia or doing studies, doing the data science, with all those relatively easy examples which are there available in open source or the public data source, we tend to think that, okay, we can write few of the Python lines, few codes, and then data science is done, right? Because nowadays you can create a deep learning model using the Keras and the TensorFlow framework. In 10 lines you can create a computer vision algorithm, but that doesn't actually solve the purpose when you actually try to implement that in the industry or the real world scenario. And I and Debanjan have combinedly over 25 years of experience in this particular area. And from our experience, we have seen that when you start working in a real world environment, the first thing you will see that there are multiple problems due to the data and due to the data access itself. So this is a generic diagram where we have tried to portray how the actual world data science or machine learning actually works. So the building on the left hand side, which is the dark blue color building, let's assume that's the enterprise, and let's assume that one of you guys have started working on there, right? So any enterprise will always try to leverage their data science or the machine learning capability, or leverage the insight they can draw from that data, because data is a new oil, right? And on that perspective, they need to share the data with their data scientists or the outsourcing partners. And there lies those two vulnerabilities. Because even if you do all those processing into a logically secured private cloud, but still you would be able to just take a screenshot, right? So say, for example, you are doing a data science work and you are doing some data analysis of some images, you are doing facial recognition, right? Even if someone actually stop you from copying that image and sending it to your Google Drive, you still can take out your mobile phone and take a photograph of that, right? So there is no practical way of actually stopping those things. Okay. So what can we do for that? So that's where our solution comes into place. Also, if you see from the cloud or software vendor perspective, there are a lot of open source software currently available. And as you may appreciate, that the open source softwares might not always be checked with all the vulnerabilities. So there can be a lot of vulnerabilities present in those circumstances. And I would like to inform and share one of those vulnerabilities, which was last year, November. The vulnerability was log4j related. That's a package, which is very well-known package in the programming world. And using that vulnerability, the adversaries were being able to get the root access to your infrastructure. That's pretty scary, right? Because if you have all those things secured and you are saying that, okay, I am securely running all those processes into my infrastructure, and someone who shouldn't have the access and with the malicious intention, they actually have the root access now. And you can imagine, if you have the root access, you can do anything, right? So those are the vulnerability 3 and 4, where the cloud provider may have some vulnerabilities. The software you are using into your laptop, into your infrastructure may have the vulnerabilities. So how safe our data is, how can we trust? So let's say enterprise A wants to work with enterprise B, and in order to create some value out using the AI or machine learning, is it only the quality of the machine learning model, the quality of the deep learning architecture, or the quality of the data? So you may appreciate it's actually the quality of the data and the amount of the data. So if enterprise A and enterprise B can work together, then the volume of the data would obviously be higher, and the quality of the data and quality of the exact product can be more useful for the world, right? So in that scenario, if those two parties cannot trust each other, they cannot share the data. That's where our technology platform comes into picture. We solve these vulnerabilities and we enable the data trust. How we do that? We have an assumption within our company that whatever we will work under assumption that the collaborative parties, and the majority of those collaborative parties, will be dishonest. We cannot trust them with the data. And under that assumption, we have came up with a 3-layer of services, where at the end of the bottom layer, you can achieve a complete zero trust environment, where only the data controller will have the access to the original data, can be able to see or edit that data, but no one else, absolutely no one else, can have the access to that data. There are 3 steps for that. And on the first step, you create a synthetic twin. As Debanjan have explained earlier, that differential privacy is one of the way how you can create synthetic twin. Into our platform, with the research we did since last couple of years, we have been able to come up with multiple other approaches. Depending on the use case and the requirement and the risk appetite the customer will have, they can use those things. The second layer of the privacy can be preserved using the remote execution. That means we can guarantee that you should not be able to share your data outside your infrastructure. Rather than you share the data, the application which will actually access the data, that can run within your premises. So without seeing the data, actually seeing the data, you can run any machine learning algorithm. You can train, you can do the inferences. See how cool that would be. Let's say you guys want to create some good value to the world. You guys want to create some cancer research machine learning algorithm. But how would you have the data? right? Because no medical institution is going to share that data with you, right? In that regard, if you had the chance to remotely execute those data and under the assumption of the zero trust environment, if you had been able to do all those machine learning without seeing the data with your naked eye, that would have been very cool, right? So we have that solution, we have that technique, and using that technique, we are actually helping enterprises around the world to achieve these zero trust environment machine learning models. And the third and the last layer of the privacy preserving technique is the trusted execution environment. There are cutting edge hardware research have been done, and recently Intel have came up with something called software guard extension. Using that, you can detach all your processing from the RAM of the existing host machine using something called hypervisor. And using that, we can guarantee that data would be encrypted even when it is in processing, right? So using that technique, you can actually encrypt the data into the whole end-to-end life cycle of the data processing. That's how you can guarantee in the whole life cycle there would be complete zero trust, that only the data owner or the data controller will have the access. This is a very high level overview of what we do, how we do it. There are two logical segregation of our platform. One is the zero trust module, where you can create the machine learning model under the zero trust environment. And the second is confidence module, that once you have that model, it's not enough, right? Because you can easily say, we are working with a customer, with a bank who wants to predict the loan application, right? So let's say, for example, you have put your application to one of the bank for the loan, and they said, no, your loan application is rejected, right? So then it's the onus of them, the responsibility of them to explain why your loan application is being rejected, right? So if they are using a machine learning algorithm in the back end, then the machine learning algorithm should be able to explain or give you the cause that why your loan application is rejected. So that's the confidence module we have. Under that confidence module, we have the explainability, that whatever the decision of the machine learning model, that can be explained. Second, we have the causality. There is a subtle difference between the explanation and the causation. We would not go deep into that because that would take another day to actually discuss about that. And the third module is the model guardrail, where you can observe the models so that you can continuously observe and improve that model, whether you have any model drift or the data drift and all those things. Using this platform, what you can achieve here is zero data leakage, removing the burden of trust from the partner because you are working under zero trust environment, and full control of the algorithmic decision making process, easier business performance management, and all those things. So that's the thing we currently have as part of our technology stack, and we are constantly innovating, doing the research on this area, because we believe this area has not been actually uh, progressed from the research perspective so much in compared to the AI and machine learning model has been progressed. Like we currently have all the state of the art NLP model like GPT-3, GPT-2, and all those things. We have the computer vision models, but actually with use of those models, still the enterprise are struggling because they don't want to share the data. And that's where we are trying to create the value in this ecosystem. Couple of approaches how we can use this technology. As Debanjan have already mentioned, that one of the processes is the differential privacy. So let's say, for example, you want to do a face recognition, right? You have the face images, you use the technology we have built, and the technology would be able to give you a synthetic twin so that you cannot actually see who those people are or what faces are. It's just one of the toy example, but it can be run on other images. on text data, on structured data, on audio data, anything you name it, you can run it. Okay. And then you can share that data. So as you can see in the second column, all those data some sort of garbled up, right? So you cannot make sense out of that data. Then you give that data to a machine learning model, because in a machine learning model, everything is matrix, right? So it doesn't matter whether you can see it or not. So they can still make sense out of that. They can still get the features and they can still do the recognition. And once you can do that, we have built this method in such a way so that you don't compromise with the utility. And when we say utility, utility means how well this model is performing on that classification task or on that regression task. Whatever the task may be, we call that as utility. And on the second layer of the security, as I discussed earlier, that you should be able to run your code without seeing the data remotely. On that stage, we have 4 different processes. One, whatever the code you have written, you can package it. Then let's say you don't want to share the code with the person who will run that, right? So you can obfuscate to protect your intellectual property. So obfuscate the code as well. Then you can do the execution settings, configuration, whatever the configuration you need to do, from where the data will come, which database, which file. So this is basically the execution configuration. And once you do the execution configuration, you can actually run that particular code, giving that IP and the port number that where you want to run that remotely. That means in order to train a machine learning model, you don't have to see that data. Without seeing the data, without seeing the actual data, you can still build the machine learning model. That means the enterprise shouldn't always have to share the data with the third-party vendors or the experts like you. And that's how we believe that the whole thing can be, the whole innovation can be accelerated. While doing all of those things, we have a great partner whom we have done the partnership with. They are Thermify, because in this privacy processing, it's usually a batch processes, and they have came up with a very innovative way of doing the batch processing. And using the batch processing, whatever the heat they generate, they reuse that heat to boil the water and all those things in the country like UK, US, where the household users are actually using the heaters, right? So we have this great partner Thermify, with whom we are actually delivering these privacy processing if a customer is interested. So that's all from the presentation perspective. And if you have any curiosity how we are doing, or if you are actually working in a project, or you have been working in some use cases where you have seen, okay, this privacy preservation might be useful, then please feel free to just send us an email at info@arkvien.ai. We will be able to give you a free self-assessment tool where you can assess by yourself what is a privacy measurement framework. And for any other queries, you can just ask us. We have already given the email ID of us, and when we will share this as a PDF format, you would also be able to see that. And the other things what we are currently doing, you can check us at https://arkvien.ai. That's all. So if you have any questions, we would be happy to answer those.
Thank you so much. It was indeed an eye-opening session. And the quote, actually, I'd like to quote you when you said the data is the new oil. So I could really understand the worth of the oil coming on. I don't suppose there are questions. Okay, there is a question. A user asks, "What is the difference between data masking and data obfuscation?" So, if one of
From
you could take that.
Yeah, sure. So
Maybe
from
I can,
English,
yeah, okay, sorry, please.
okay. So I was just trying to answer it on a lighter note, that from English grammar perspective, I believe masking and obfuscation is the same thing or a similar thing. But from a technical perspective, Masking is often understood as you identify the name, identify the organization, identify the contact, and you just mask those things. Okay, but let me tell you a quick phrase. If I tell you this sentence that Roger Federer, Rafael Nadal, and Novak Djokovic were three greatest men's tennis players, right? And if you do the masking on top of that, you would obviously be able to understand, okay, Roger Federer, Rafael Nadal, and Novak Djokovic, they are the players, right? But does that really solve that problem? Because after masking, you give that data to someone, and that someone can just see that three greatest men's tennis player. They can try to search in the Google, and you also can search in the Google. Just write big three men's tennis player. You would be able to see those players' picture, right? So only masking doesn't solve the privacy issue, and there comes this contextual obfuscation. Debanjan, if you want to add anything on top of that.
Yeah, as I also mentioned, like in case of the tweets, like if you just mask the name or organization, it's not enough. So I mean, you can look into the tweets, and then from the context of the tweet, you can guess the name of the person or organization in general. So this is like technically possible if you have deeper understanding of what you are masking. So what we are doing at Arkvien is like we are having this deeper underground knowledge where we are trying to understand that, okay, what are the things that are being masked and how can this be related. So this knowledge we are using to obfuscate the data rather than only simple masking. So this is the main underlying difference between masking and obfuscation. I hope we have answered that.
Yes, indeed. The other question is, how can Arkvien AI provide opportunities of data science and programming graduates? For data science and programming graduates, yes.
Yes, of course, because as we have shown the technology and the depth of the technology we are building. So as you may imagine, the amount of effort we are putting into the R&D activities, putting into the development, and the engineering effort we are putting into there. So we are already in touch with Aishwarya and her team to actually try to work out some way so that the graduates can actually create some value through RVN in this world.
All right, I think that sums up the questions that we have. I I think we can wrap up.
Okay,
If there's
that
anything you would like to add as a final note, Mr.
as
Debanjan
a
or Mr.
final note, I
Sourish.
would like to add that this particular problem of the data privacy is a bigger problem, but often we don't know. And also, I mean, obviously in UK, US, they have the pioneer of doing the data privacy initially, but you have probably have seen China have came up with their own version, Israel have came up with their own version. Every country is coming up with their own version, and hopefully very soon India will also come up with the own version of the data privacy law and all those things. And then every enterprise. So when any graduate from the college will go start working on any enterprises, the first thing they will face the problem of these compliance regulations and all those things. So from that perspective, I believe that this is one of the key area where we need to focus, at least when we are helping the people to understand data science and this area. So I will have a chat with the team that if we can jointly create some course for the students, so that the students can actually have being able to understand and hands-on experience how they can do these things.
That would be great. Mr.
Yeah,
Debanjan?
yeah.
Yes.
So first of all, thanks for organizing this session. And like yeah, as Sourish has mentioned, like feel free to contact us if you are interested more in this. So this is definitely like data is something which we don't understand that we are giving what we are giving to the world, but like unless it is being exploited, for instance, if it is exploited once, then like your whole privacy is gone. So data is privacy is something we should be taking very seriously. And yeah, as Shoris again has mentioned, like like we are looking forward to have people to work with us to work on this topic and solve different research problems as well. So yeah, that's it from my side.
All right, thank you. And thanks, Sourish, for the idea of the course. I think I'd be looking forward to it. I would like to thank POD team and the whole organizing team for having such a wonderful session and indeed an informative one. Um, I think we can wrap up now.
Thank you, guys.
Thank
Cheers.
you. Thank you.
Have a nice day.
Likewise.